First of all, I would like to say something because you see here three names. So I'm the presenter today, but the two main researchers for this IFA project were Florian Seuker and Herr Simons, but both are on holidays today, so I present their results. So the IFA project was based on using augmented reality for our measurement of electromagnetic fields. Here you can see our measurement equipment we use today and which was developed during the project. And before we go into detail, I would like to go to the regulations we have to fulfill. So the question is, why do we have to carry out measurement of electromagnetic fields on workplaces? So there you can say every employer have to protect their workers from potential risks of electromagnetic fields. And of course, there's an European directive for that. And in addition, you have several national laws depending on the regulation for example, you have the German electromagnetic field audience in Germany, and you have another in other nations. And if you look in these regulations, you find limit values for the specific electromagnetic fields, and that is the reason why we have to carry out electromagnetic fields measurements at every workplace normally. So here you can see what the effects are. If you see on the right side, you have some, okay, normally it's activated, okay. So you have different kind of electromagnetic fields. For example, in low frequency electromagnetic fields can affect active implantable medical devices in such a way that they will not work correctly if you are in this field. In addition, you have to look at static fields arising, for example, from permanent magnets. And if an implant is inside such a field, it could be possible that it is worked not correctly anymore. And that's the last one. You have on some source fields very high frequency electromagnetic fields, and there is possible that some metallic objects inside your body will heat up. And that's the reason why it is so important to look at the electromagnetic fields on workplaces. Okay, so where do we come from? So before our project, we have done this measurement several times. Normally you have one field source. So here is a one-point welding machine. Then you use some yardsticks in combination with measuring devices, and normally you wrote down your measurement values in an Excel sheet and then evaluate this. And for this kind of measurement, we need around about 2 or 3 people. One people using the yardstick to look where the measurement takes place. One people holding the measuring device, and another people who write down all the information in the Excel sheet. So it was very complicated to do such a measurement, and that was the reason why we thought we could make it a little bit better. And that was the reason why we have started the project. So here you can see our new measuring setup. Of course, you have the same measuring device and the same field probe, but we have a new mounting device that's right now a 3D printed mount where we can fix the measuring device, and in addition we can put there a mobile phone. On the mobile phone there's an app with the augmented reality, and the mobile phone and the measuring device is connected via an USB-C and an optical connection to communicate with each other. So that's why the measurement values from the measuring device can come to our mobile phone and to the augmented reality. Here you can see the software we use for this. The app development was done in Unity using C#. We have used the software development kit AR Core from Google for the augmented reality. And you see it here above. We use the real-time database Firebase from Google to create a second device where we can look at the measurement when it's done. So the whole process, I have a video for you, so you can see how we measure right now in electromagnetic fields. First of all, we have to scan our surrounding of our machine. So that's for the augmented reality. Then we have to place a reference point for our measurements, and then we can start our measuring. So that's, you can see here, that's the distance between the measuring probe and the reference point. And now you are able to place your measuring points wherever you want. Here's the first one, here's the second one. And of course, you can see right now what you are measuring, and we have implemented the regulations regarding the electromagnetic fields, and you can switch during the measurements between the regulation to see how it is affected. And of course, you can see here, if the limit value exceeds, the balloon goes to a red, and if everything is okay, you get a green balloon. And in addition, we have implemented a visualization of the safety distances, because if the electromagnetic fields are too high, some workers are not allowed to work at the source field. And so you can here implement a warning field to show the workers where they can work and where they do not work. Yeah, of course, you can change the range if you want from the mobile phone to the other. And here you can see that's the second device, and we are able to do the measuring with our measuring equipment. You can see it here. And here you have now the view from the second mobile device. So that's very important, because normally you have more than one person working on the machine. And during the measurement, you have around about 4 or 5 persons, and then it's very easy to show them the measuring during the second device. And that is the output of our augmented reality measurement. Normally we create a report afterwards so that the company get to know what we have done and of course what they have to do in the future. And right now we use the photos coming from the AR with our measuring points, and we implemented them to the report. And in addition, we have done around about 10 measurements with this, and it is very easy to understand for the people if they see this kind of cube that they are forbidden to work in such an area, and for us it's a very, very helpful thing. So to evaluate this method, we create a short questionnaire, and we asked 15 people. That's not that much, but I think it's okay for the moment. So we have done the measurement, and we created 2 kinds of reports. The first one is a classic report we've done in the past without using the AR pictures. And we have created an extended report using the AR figures we have created. And if you can see on the slides, if you use an extended report, it's much more understandable for the people. So they get better to know what we try to tell them, and they are able to understand everything correct. Yeah, and what are the goals for the future? Currently, we discuss if it's possible to transfer such an augmented reality measurement to other physical phenomena. So maybe we can measure noise or temperature in the future using the augmented reality. And of course, we think about other technologies for such kind of measurement. So maybe next year, we will do this measurement using a tablet to have a wider screen to show it much better. Or we are in discussion with a company who maybe transfer this measurement to a Google Smart Glass to do this measurement. And yeah, we think about some other things, but right now I think that's the goals for the future we have to carry out in the next 2 years. So here are some literature for you. So the first link is to our DGUV site, where everything is posted regarding the electromagnetic fields and, of course, the measurement. And if you like to go more in detail of what we've done in the project, you can use the second link. So that's in a publication from Mr. Soika and Mr. Simons regarding the project. Okay, I think that's all. So I would like to thank you very much for your attention. I hope you enjoy my speech, and maybe there are some questions. Thank you.